Welcome to another video on my Arduino Mega2560, which is connected to a breadboard with electronics and one switch of fischertechnik. And this is the second series of videos, and in this series I have changed from C to Octave, mathematical programming language, in which I can do data acquisition and put it in a matrix, because that is what the mathematical software does. Last time I had some problems with, once again, the data as a result of the pulse modulation, increasing, decreasing, as well as with the backlash voltage from this part of the circuit. You don't see it quite well. Last time I disconnected the resistor from the 5 volts to see what the result was. It didn't really convince me, but what I found now by studying the documentation of the Octave package is that apart from reading just the analog input right here from this wire in that direction obviously, and from this wire also in that direction, so from the circuit to the board, reading analog, but there's also a read voltage function, and guess what, I'm going to use that. I didn't even know it was there, but reading documentation reveals a lot. So now I am very curious, by the way, not replacing the read analog, but adding two read analogs, so they are both different functions and I'm using both to see whether those values are the same. Because the value can be anything, but the voltage is a voltage. Is it the millivoltage? I have no idea. The example shows that it might be voltage, expressed in 3 decimals. So since this is 5 volts maximum, we'll see whatever it brings. And I might reconnect the resistor to the 5 volts to see if that really makes out or makes a difference. Anyway, so much for introduction. Let's go to screencast and see whatever happens. Alright, so talking about voltage, read voltage here and a read voltage here with some different variables, actually not variable but a vector, which is rather logical because they are reading the same pin. And then of course let me change that a bit, because now you cannot really see the colors, not as clearly. So, it's set to, so yeah, you should be able to see. Yeah, blue, purple, light blue and green. Yellow actually. Anyway, I haven't saved it yet, so let's do that. Then press the button, and the button is F5. So now it starts working, and then I will have, right, that's a nice one. This will work better. Then hold it and go. Of course, I will see nothing at first. And on the oscilloscope you can see whatever is happening. And the purple one is the signal that goes to the board, to the voltage pins. Do I see a red LED already? Did I miss it? I probably did miss it. But yeah, I must have missed it. It's decreasing now. Then in the end I should see a red LED. Unless I let go and end of it. What is going wrong? Which is going wrong where? This is 52 and oh, now I see why. Yep. The 52 wire has gone out again. Then you will never see that signal. Okay, this is it. So I will assume there is something. Now let us see. Right, so here it goes. 1 is okay. Not okay. What a surprise here. Oh wow. Now that is a surprise. Voltage. This is very different from what I'm reading. This is very different from here. Wow. So actually there is a voltage of 0.83 volts and here 1.5 volt. So what is this value then? Clearly not voltage. Very clearly not. But what's the connection? I have no idea. 1 is okay again. Not okay again, and voltage. 72 against 0.4. 262 against 1.4. 1.5 rounded. Here again. Really? Yeah, okay, now I'm kind of very surprised. So I believe the voltages, but what are the other values then? I don't know. Alright, so two strange things now. First I have here read and log pin. I have read voltage. They're reading both the same pin, A0, which is analog input. Same for read analog pin A1 and read voltage A1, both the same pin, analog input. So where are they? One is on this side one is on this side of the LED. However, okay, so because on the other side it can be a different voltage, and I will assume it is, although here it is actually very low because this one is not connected anymore to 5 volts. But according to the information, read analog pin also reads the voltage. So if so, then why is this so completely different? If this would have been, let's say, 850 instead of 0.850, I would have understood. But that's not the case. So thinking like that, what can I do more? Adding another analog voltage. I would not know what that would bring in. Let's take here a look. Let's take a look here. This is right here, still connected here. So this is 5 volts. This part is not connected, so this gives 0. But this does not give 0 since A1 gives A1 gives 350 and 122. Okay. And this gives 3 point something, if I'm correct. No, even lower. A4 gives even lower. Sorry, A0, right? A0. Yeah, A0. V4, A0. Right. So how can I expand the things they do? Put something from here. That will be a nice one. This is the one that blinks the most. So if I put a wire from here to A2, that would be something else. So let's do that. From here to here. Looks like a good idea to me. Yeah, so that's going to be a new one, which I have to give a name, of course. And this is V6, and then this will be V7. V7 versus V71, and this will be a little bit here, so that's better. Save. So let's wire this up somewhere from here. So this wire will go from, and now I have to be a bit careful where to put it. Again, it's a bit rough wire. I don't want to do in my own shadow. This is going to a 2. Right. And in the meantime I undid this one, so right, all wires set, I think. Then back to this one. That will be then this whole thing. Copy here, where we will have V7 is A2, A2, V7, V71, A2, A2, and 71. See if that gives the same stuff that I'm having now with the already existing ones. Hopefully different voltage, but same values, which I don't expect. So with all this, let's run again, holding the switch, and go. And then I hope there's no error. No, there's no error. I just have to hold the switch. For some time. And I also notice that I am blocking the camera view from the red LED, which is right behind, like here. So now you can see it, or should be able to see it. Yep, that's one cycle. Second cycle. And upon the third cycle completed, yes, thank you, and end. Alright, now let's look at this. Okay, just going further. Okay, well, this one is no surprise anymore here. But what are the outcomes? Voltage 112 versus 0.45. 291 versus 195. 269 versus 132. Okay, is there a relation between those voltages? I honestly don't know. So the difference here is 150. 1.5 difference between this one and this one. What's the difference here? 180. 150 versus 180. This is roughly 0.7, and this is 70, this is 20. I think it's strange. Okay, guess this. Now suddenly it is okay. The second one is okay. Which also means that I should have seen the green LED, which I haven't seen. Burn, that is. So, another mystery added. Okay, then this one is not okay again, and yeah, I'm at a loss. So, again, more questions and answers. Why is the second loop mostly not okay and sometimes okay? And what is the difference then between read digital pin and read analog? Read analog pin and read voltage. According to the documentation, they are both reading voltage. Really? Okay. Adding to mystery. What I want to do is automatically extending the vectors that I have from V1 till V7 and 71 to get a nice graph out of it, or at least a nice table, because now when I do this I get only one value. This is a 2 value, etc. So this is 2 by 1, and then according to some info they say, alright, V1 2 by 1. Would that work out? Yeah, because then you have suddenly something else. What about 71? You have the same IDs. The only problem is I would have to assign something, but there's one issue though. They're not always the same values, which I do want. So this is repeat the matrix. That's not what I want. I want the matrix to be extended by data acquisition. And that is not happening that way. So I think, although I'm not quite sure yet, see here I fill it by 2 by 1. And I want to make that then say 8 by 1. And then this is 1 by 1. This is 2, 1. Next thing, and that's a problem. This is a while. So next thing is going to be 1, 1 again, not 3, 1. Unless, of course, I make this a variable like I or X or whatever, and each end of the while I say, alright, enlarge it with 1. Then it would be possible. But how much do you want? 4 times? So So then it would be here like 2 is 1 loop, 3 loops would be 6. Then you would say V1 and V1 whatever, E would be 1. V1E, V1E plus 1, something like that. And then this would be something like V1E plus is 2. Would this work out? I have no idea. For the last few minutes of this video, let's just try it out. If not, I'll reverse it. So, go. And let's keep this under, okay. Right, that's 1 loop. This was the second loop then. Third loop, yep. Right, let's quit this and see whatever has happened. So not okay, etc, etc. Now I want to see what V1 is. Alright, it's been filled. Now let's see whatever 061, yes. And how is this? Is 7 by now. So that looks like the way to go. The only thing is I would have to do it for each matrix that I have. Each vector that I have. One element vector becoming a lot of vectors. Now would become longer vectors. And I think I'll postpone that to next time. And that's it for now. So, some wiring, some new way of acquiring data using read voltage, which gives a very different value. New wiring and new ideas for making the data acquisition go more logical. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please donate to keep videos coming to you. To show your support via PayPal or Wired. More information on my website. And you can also become a patron and have your name mentioned as a supporter. All voluntary, of course. But please do. and more information on becoming a patron on my website, which is listed under this video. This is going to be continued. Have a nice day.